Question number 10 now. Our final one. Alright, a uniform plank. AB has weight 100 newtons and length 4 meters. The plank rests horizontally in equilibrium on two smooth supports C and D, where AC is X and CD is 0.5. The magnitude of the reaction at C is 75. Modeling the plank as a rigid rod, find the magnitude of the reaction at D. This is 1 mark, so it's going to be something quite straightforward. Well, they told us that at C, the reaction was 75, and we knew that the rod had a weight of 100 newtons. So we can do upwards equals downwards, and so the magnitude of the reaction at D is going to be 25. So this is 25 newtons. Now we've got to find the value of X. In a moments question, you can take moments about any way you want. But usually it's a good idea to take moments about a place where there's a force. And that way you can ignore that force. So in this case, I'm going to take moments about, let's see, what would be easier. Ironically, in this one, I think it'll be easier to take moments about A, even though there's no force acting at A. The reason I'm taking moments about A in this question is because I know the distance from A to C is X. And that's going to be helpful because I don't know my distance from A to D either. I just know that the distance between C and D is 0.5. Okay, so if I took moments about C or D or the midpoint, it just would have been a little bit awkward to calculate those distances. So, having said what I said before, I'm going to ignore that now and then take moments about A. So, from A, first force we come across is 75. This is 75 Newton force. And it's going to be 75 is the force and the perpendicular distance. Vertical force, perpendicular distance is the horizontal distance. So it's going to be 75 times by X. And that's going in an anti-clockwise direction. So we're going to do a little anti-clockwise direction there. So at the moment I've got my anti-clockwise as positive. It doesn't matter which one you make positive and negative, as long as you're consistent throughout the question. Now, let's see, the next force is the 100 Newton force, which is the weight of the particle, and that's going to act in a clockwise direction, so I'm going to leave that as negative here. Okay, so it's going to be 100 newtons, and because it was a uniform rod, this 100 newtons acts in the middle, and so that's going to be 2 meter distance. So it's going to be 100 times 2. And as I say, all of this is a lot easier now because I chose moments about A, so these distances are a lot nicer. And finally, I've got my 25 Newton force. Now the 25 Newton force acting upward is going to turn it in a anti-clockwise direction. And I had anti-clockwise as positive, so that's positive. 25 times my distance from D to A is X plus 0.5. And that's all equal to 0. Now I can solve. So 75x minus 200 plus 25x plus 12.5 equals 0. So 100x is equal to 187.5. And so x is 1.875. As I mentioned in my previous video, write out the full answer, and then if you want round it afterwards, round it afterwards. But I would recommend with this one, it's just 1.875, just leave it like that. And that's fine. Now, in looking at part 3, so here we're told that a stone block is which is modeled as a particle, is now placed at the end of the plank at B. And the plank is on the point of tilting about D. So as soon as you read that it's on the point of tilting about D, you can put the reaction at the other pivot as 0. Okay. And then it says find the block, find the weight of the block. So we don't know the weight of this block, this particle at B. Let's just call it W. So that's for the weight. There's no force there, it's just A. Right. And we're going to have a reaction here. And we're still going to have the weight of the rod as 100 newtons. I know my distance here now is 1.875. I know this distance between C and D is 0.5. I also know this distance here is 2. So I can fill in little distances here. So that's going to be 1.625 meters. So that's 4 minus 1.875 plus 0.5, and you should get 1.625. So straight away, generally what you can do is just write down upwards equals downwards. So upward force is R, and the downward force is 100 plus W. Now we might use this, we might not use this, but it's a good idea just to write it down. It's quite quick and easy. Right, so I'm going to try and find W. So my R is the only other unknown. So if I take moments about D, then I can ignore R altogether and just find W. Right, so I've got two forces. I've got the 100 Newton force. Remember the force at C, the reaction at C is 0 because it's tilting. So I've got 100 Newton force, and that's being multiplied by the distance here. And because that's in the middle, the 100 Newton force is a uniform rod, it's in the middle, so I make this distance 0.375. So that's going to be 0.375. And that's because I knew this was 2, and then I got the 1.625. So therefore, if I do 2 minus 1.625, I get that. And then that there is going to make it turn this way around, so anti-clockwise. So I've got anti-clockwise as positive again in this one. And then the W force is going to make it turn clockwise, so I'm going to have that as negative. And it's W times Y, 1.625. It's on the point of tilting, but it's not actually tilting, so this is going to be equal to 0. And so this is 37.5 is equal to 1.625 W. And if you solve that, you should get W as 23.1 newtons. Okay, this is 23.07, I just checked, but you can round that to 23.1 newtons. Right, final couple of parts. So IV, part A. Explain the limitation of modeling the stone block as a particle. Oh, these are kind of definition things that you need to learn. So when we model the stone block as a particle, we're going to assume that the weight acts exactly at B, and therefore we're ignoring the dimensions of B, of the particle. So we're going to ignore the dimensions of the particle. That's essentially what we're doing. Or we're not taking the dimensions of the particle into account. And the plank as a rigid rod. So when we're modeling it as a rigid rod, we're assuming that the plank is a straight line and it does not bend. Assume plank remains straight. And doesn't bend. Right, so the whole idea of a rigid rod is the one that is one. Okay, thanks for listening in on this, and good luck with everything.